Good morning, students. In this class, we are going to be discussing about the laws of chemical combinations. Means the combination of elements to form a compound. That is the combination of elements to form a compound. That is governed by these five laws. How the elements combine to form a compound. ಅದನ್ನು ನಾನು ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತಾ ಹೋಗುತ್ತೆ ಈ ಫೈಲರ್ಸ್ ಅಂದರೆ ನಮಗೆ ಎಲ್ಲಿ ಯಾವ ಫೈಲರ್ಸ್ ಇದು ಲಾಸ್ ಆಫ್ ಕನ್ಸರ್ವೇಷನ್ ಆಫ್ ಮಾಸ್ ದ ಫಸ್ಟ್ ಲಾ ಈಸ್ ಲಾ ಆಫ್ ಕನ್ಸರ್ವೇಷನ್ ಆಫ್ ಮಾಸ್ ದ ಸೆಕೆಂಡ್ ಲಾ ಈಸ್ ಲಾ ಆಫ್ ಡೆಫಿನೆಟ್ ಪ್ರಪೋರ್ಷನ್ ದ ಥರ್ಡ್ ಲಾ ಈಸ್ ಲಾ ಆಫ್ ಮಲ್ಟಿಪಲ್ ಪ್ರಪೋರ್ಷನ್ ದೆನ್ ಫೋರ್ತ್ law is that is Gay-Lussac's law of combining volumes. Then fifth law is Avogadro's law. We will study these laws one by one in this class. The first we are going to be discussing about the law of conservation of mass. That is law of conservation of mass. This law was proposed by the scientist that is Antony. That is Antony Lavoisier in the year that is 1789. In the year 1789 means the law of conservation of mass. ಈ law na propose ಮಾಡಿದ್ದು ಯಾರಂದ್ರೆ ಆಂಟೋನಿ ಲಾವೆಸಿಯರ್ in the year 1789. This law states that the mass is neither created nor destroyed. Means during a chemical reaction, ಯಾವುದೇ ಒಂದು chemical reaction ಆಗಬೇಕಾದ್ರೆ ಮಾಸ್ ಕ್ರಿಯೇಟ್ ಮಾಡಕ್ಕಾಗಲ್ಲ ಮತ್ತೆ ಡಿಸ್ಟ್ರಾಯ್ ಮಾಡಕ್ಕಾಗಲ್ಲ ಅಂತ ಹೇಳ್ತಾರೆ. That is the statement of the law of conservation of mass. Means law of conservation of mass, that is this law was proposed by the Antony Lavoisier in the year 1789. This law states that the mass is neither be created nor be destroyed. Neither created nor be destroyed. Means ಒಂದು ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಆಗಬೇಕಾದ್ರೆ the mass ನ ಕ್ರಿಯೇಟ್ ಮಾಡಕ್ಕಾಗಲ್ಲ ಅಥವಾ ಡಿಸ್ಟ್ರಾಯ್ ಮಾಡಕ್ಕಾಗಲ್ಲ ಅಂತ ಹೇಳ್ತಾರೆ. Then now we are going to see the example for this law of conservation. ಏನ್ ಸ್ಟೇಟ್ ಮಾಡುತ್ತೆ ಸ್ಟೇಟ್ಮೆಂಟ್ ಬೇಕಾದ್ರೆ ನೋಡಿ. That is mass is neither be created nor be destroyed. This about the statement of this law. Then let's take some example for this law. That is ಏನು ಹೇಳ್ತಾರೆ, ಒಂದು ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಆಗಬೇಕಾದ್ರೆ ಮಾಸ್ ನ ಡಿಸ್ಟ್ರಾಯ್ ಮಾಡಕ್ಕಾಗಲ್ಲ ಮತ್ತೆ ಕ್ರಿಯೇಟ್ ಮಾಡಕ್ಕೂ ಆಗಲ್ಲ ಅಂತ ಹೇಳ್ತಾರೆ. In that we will see that one chemical reaction, that is decomposition of mercuric oxide. We take the decomposition of mercuric oxide, HgO. This we call as a mercuric oxide. This undergoes the decomposition. If suppose 10 gram of mercuric oxide is going to be decomposed into mercury and oxygen. Here, the mercury is containing the 9.26 gram. Then this having the 0.74 gram. Means in this reaction you can observe. This reaction ನೋಡಬಹುದು ಎಷ್ಟು 10 gram of mercuric oxide ನ ನಾವು ಡಿಕಂಪೋಸ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ it's going to be formed in 9.26 gram of mercury and 0.74 gram of oxygen. That is we need to balance the equation here to Hg. Here 0.74 gram of the oxygen. Means in this reaction we can observe that the 10 gram decomposes, 10 gram of mercuric oxide decomposes, that is 9.26 gram of mercury and 0.74 gram of the oxygen. By addition of these two we get that 10 gram. You can check it out. That is 9.26, 0.74 gram. Then you get that. That is you will get that 10 gram. Means it's going to be mass is not be created. That is cannot be created nor be destroyed. The mass is neither be created nor be destroyed. This I will take some other example for this. If you are going to be the decomposition of calcium carbonate, there is some other example. Another example. The calcium carbonate. We take the calcium carbonate. This undergoes the decomposition. Into calcium oxide is going to be formed as calcium oxide plus the calcium oxide and the carbon dioxide. We will get that carbon dioxide. Here the 56 gram of, that is 56 gram of calcium oxide is going to be formed. Then remaining 44 gram of carbon dioxide is going to be formed. Then here suppose 100 gram of calcium carbonate is decomposed. Now 100 grams to calcium carbonate na decompose ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ 56 gram of calcium oxide and 44 gram ಅಷ್ಟು carbon dioxide ಬರುತ್ತೆ ಅಂತ ಹೇಳ್ತಾರೆ. Means the addition of this 56 and 44 will get that 100 gram. Means ಇಲ್ಲಿ mass create ಮಾಡಿಲ್ಲ, ನಾವು destroy ಮಾಡಕ್ಕಾಗಿಲ್ಲ. ಎಷ್ಟು ಪ್ರಾಡಕ್ಟ್ಸ್ ಅಲ್ಲಿ ಎಷ್ಟು ಮಾಸ್ ಇರುತ್ತೆ, ರಿಯಾಕ್ಟೆಂಟ್ ಅಲ್ಲಿ ಎಷ್ಟು ಮಾಸ್ ಇರುತ್ತೆ is equal to the mass of the product. Means the mass of the reactant always is equal to the mass of the reactants. ಅಂದ್ರೆ ಪ್ರಾಡಕ್ಟ್ಸ್ ಅಲ್ಲಿ ಎಷ್ಟು ಮಾಸ್ ಇರುತ್ತೆ, ರಿಯಾಕ್ಟೆಂಟ್ ಅಲ್ಲಿ ಕೂಡ ಅಷ್ಟೇ ಮಾಸ್ ಇರುತ್ತೆ. ಮಾಸ್ ಯಾವುದೇ ಕಾರಣಕ್ಕೂ ಡೆಸ್ಟ್ರಾಯ್ ಆಗಲ್ಲ ಅಥವಾ ಕ್ರಿಯೇಟ್ ಮಾಡಕ್ಕೂ ಆಗಲ್ಲ ಅಂತ ಹೇಳುತ್ತೆ. This is about there is a law of conservation of mass. That is, the mass is neither be created nor be destroyed. That is about the statement of the first law. Then the next we will be discussing about the second law. That is the law of definite proportions. This also be called as the law of definite combination. ಅಂತನೂ ಕರೀತೀವಿ. This we will discuss now. That is the law of definite combination or law of definite proportion. That is now we will discuss about the second law. That is the law of definite proportion. This law was proposed by, that is Joseph Proust in the year 1803. This was proposed by, that is the law of definite proportion was proposed by, that is the Joseph Proust in the 1803. This law states that state ಮಾಡುತ್ತೆ law. Then this is the given element, that is a given compound always contains a given compound always contains exactly same proportion of elements by mass. Same proportion of elements by mass. Means this law states that a given compound contains exactly same proportion of elements by mass. This about the statement of law of definite proportion or law of definite combination. It is also called as a law of definite combination. Means a given compound contains exactly the same proportion of elements by mass. We will take the explanation for this. Means we will take the well-known example, that is water compound. I will take the compound is an example. That is water. The water is obtained by the natural source. It is going to be obtained from the natural source. Means we are going to be obtained, that is by rivers or rain, from lakes, anything. That is the, it contains the, that is the combination H1:8 ratio. That also. Then the water we are obtaining by the synthetic method. Synthetic method means the preparation method. That is combustion of, that is can be obtained by the burning the hydrogen in the oxygen. Burning the hydrogen in oxygen. At that time also we are obtaining the water. Means here the two things is there. Natural method. Then synthetic method, obtaining the product. Here in the natural method means we are obtaining the water from the lakes, and that also contains the 2 gram of hydrogen and 16 gram of oxygen. This also the synthetic water, that is the natural water. Then synthetic, that is prepared water, that also contains the 2 gram of hydrogen plus 16 gram of oxygen. Means it indicates that that is the water is in the ratio, that is the 2:16, is can be written as 1:8 in the same proportion. It is the source may be vary in the formation of that compound. We are getting from the compound source ಯಾವುದಾದರೂ ಆಗಿರಬಹುದು ಆ ಕಾಂಪೌಂಡ್ ಬಗ್ಗೆ, but it's having the definite proportions. ಇದೇ ಪ್ರಪೋರ್ಷನ್ ಇರುತ್ತೆ. ವಾಟರ್ ಹೋಗ್ತಾ ಲೇಕ್, ಸಪೋಸ್ ನಾವು ಕೆರೆಯಿಂದ ತಗೊಂಡು ಬಂದಿರೋ ವಾಟರ್ ಆದ್ರೆ ಒಂದು ರೇಷಿಯೋ ಇರುತ್ತೆ, ಮತ್ತೆ ಓಷನ್ ಇಂದ ತಗೊಂಡು ಬಂದಿರೋ ವಾಟರ್ ಆದ್ರೆ ಇನ್ನೊಂದು ಪ್ರಪೋರ್ಷನ್ ಇರುತ್ತೆ. ಆ ಥರ ಇರಲ್ಲ. The water means always it contains exactly same proportion of elements by mass. There is the same proportion of elements by mass. That about the law of definite proportion or law of definite combination. The next we are going to be discussing about the law of multiple proportion. This law of multiple proportion we will discuss now. This law was proposed by Dalton in the 1803. Dalton, the scientist Dalton has proposed this theory, law of multiple proportion. That is the law of multiple proportion. This law was proposed by Dalton in 1803. That is this law was that is proposed by the Dalton in 1803. What it says that the law of multiple proportion, it states that when two or more elements combines to form a, that is two or more compounds. That is when two or more elements combines with each other to form a two or more compounds. The mass of one element that combines with a, that is a fixed mass of the other is in a simple whole number ratio to the one another. This about the statement of that is law of multiple proportion. This you are going to be understand. This statement yavaga artha agutante, we will see the one example. That is, if you are going to be, that is, in two or more elements combines with each other. We will take the hydrogen and the oxygen. Hydrogen plus oxygen. Oxygen. It's going to be formed that. It's going to be formed that one is water. The one is water. It's a possibility of getting the water. Another one, the hydrogen plus oxygen. It combines to form a hydrogen peroxide. Hydrogen peroxide. That is the hydrogen peroxide. Here, this molecular formula is H2. This molecular formula is H2O2. H2O2. Here, this is about the 2 gram of hydrogen, then 16 gram of oxygen. 16 gram of oxygen. Then this is about the hydrogen, 2 gram of hydrogen and 32 gram of oxygen. 32 gram of oxygen. Here the statements, what it says, when 2 or more elements combined with each other. 2 elements here. I took the in the example 2 elements. This example alli 2 element ಮಾತ್ರ ತಗೊಂಡಿದ್ದೀನಿ. 2 elements combines with each other. In the both the reactions you can observe, it is the formation of the combination of the 2 elements. The combination of 2 elements only. That is hydrogen and oxygen only in the first reaction also. In the second reaction also, oxygen, hydrogen and the oxygen. Here it's going to be hydrogen and oxygen combines. Here also hydrogen and oxygen combines to form a 2 or more compounds. Here it forms 2 compounds. That is the 18 gram of water. Then if we are going to get that 34 gram of hydrogen peroxide. Here you understood, I think. You are that when 2 or more elements combines to form a 2 compounds. The mass of one element, combines with the fixed mass of another. Mass of the oxygen combines with the fixed mass of the hydrogen. Fixed mass of the hydrogen means, in this you can observe, hydrogen in both the case we are going to be taken as a 2 gram only. Fixed mass of the other is in the simple whole number ratio to the one another. Then the mass of the oxygen we are going to be taken, that is 16:32, means we are going to be simple whole number ratio. We are going to get, that is 1:2. This about the law of multiple proportion. This law is a law of multiple proportion. This law was proposed by Dalton in the 1803. That is when 2 or more elements combined with each other to form a 2 or more compounds. That is it is the mass of one element. The mass of one element is combines with the fixed mass of the another is in the simple whole number ratio to the one another. Here comparing these two, it is having the simple whole number ratio. That is 16:32. We will get that 1:2. A fixed mass hydrogen. In this example, we are going to get that hydrogen. In the notes, one more example I given. That is, you can observe that. Then the next we are going to be discussing about the Gay-Lussac's law of contained volumes. The Gay-Lussac's law containing volumes. Gay-Lussac's law containing volumes. This was, that is Gay-Lussac's law of combining volumes. This law for the gases. That is this law, Gay-Lussac's law of combining volumes. This law was proposed by Gay-Lussac. That is the scientist. That is Gay-Lussac in the year 1808. 1808. This law was proposed by Gay-Lussac. This law states that when the gases combined are produced in a chemical reaction, the gases combined are produced. Combine agbodu athava produce agbodu chemical reaction alli, they do so in the simple ratio, simple whole number ratio to the one another. ಏನಾಗಿರುತ್ತೆ ಅವೆಲ್ಲ ಒಂದು ಸಿಂಪಲ್ ರೇಷಿಯೋದಲ್ಲಿರುತ್ತೆ, ಸಿಂಪಲ್ ಹೋಲ್ ನಂಬರ್ ರೇಷಿಯೋದಲ್ಲಿರುತ್ತೆ. ದೆನ್ ಅಂಡ್ ದ volume provided, all the gases are at same temperature and pressure. Volume provided to the all the gases are at the same temperature and the pressure. This is about the statement of the Gay-Lussac's law of combining volumes. This law is we'll take some example. That is suppose hydrogen combines with chlorine, is going to be forming, that is 2HCl. Is going to form the hydrogen chloride. In this we can say that one volume of hydrogen combines with one volume of chlorine, to form a 2 volume of HCl. Means the whole number ratio is, that is the 1:2. This about the explanation of that is the Gay-Lussac's law of combining volumes. Means that is the gases which combine are produced in a chemical reaction. They do so in a simple whole number ratio to the one another. Simple whole number ratio to the one another. The volume provided that all the gases at the same temperature and the pressure. This like that one will take some other example. If that is hydrogen is going to be burns with the oxygen, is going to be formed at the water. Means this is in the ratio, that is the 2 volume of hydrogen bonds with the 1 volume of, that is oxygen, is going to form a 2 volume of water. Then ratio is, that we are going to get that ratio is 2:1:2. This about that is the Gay-Lussac's law combining volumes. The next we are going to be discussing about the Avogadro's law. This Avogadro's law is very important. So many times we are going to be use this Avogadro's constant and Avogadro's law we are going to be used. That is this law is going to be states that this law is going to be states that law is going to be states that this law, that is Avogadro's law, is proposed by the Avogadro in the year, that is in the year 1811. That is in the year, that is it's going to be proposed by this law in the year 1811. Then this states that that is Avogadro's law. It is going to be states that equal volume. Equal volume of all gases. Equal volume of all gases at similar conditions. Similar temperature and pressure contains equal number of molecules. Equal number of molecules means this last states that equal volume of all the gases at similar conditions. That is similar conditions of temperature and the pressure contains the equal number of molecules. Equal number of molecules means how much equal number? That is Avogadro's constant, that is 6.022 into 10 to the power of 23 molecules. That is one volume of, suppose we will take the example for this, one volume of CO2. One volume of CO2 means at the 22 point, that is the 22.4 liters of CO2. 22.4 liters of CO2 at STP. Standard STP means standard temperature and the pressure. That is one volume of CO2 at STP contains that is 6.022 into 10 to the power of 23 molecules. This is about the example for this. Then like that we will take the some other the one volume of oxygen. That is one volume of oxygen. One volume of oxygen means nothing but 22.4 liters. At STP, standard temperature and pressure, contains the 6.022 into 10 to the power of 23 molecules. Means it contains the equal volume of all the gases. We will take the carbon dioxide gas, either oxygen gas. Equal volume is one volume only. At similar conditions, at similar temperature and pressure, contains the equal number of molecules. This we call it as the Avogadro's constant. Avogadro's constant is, that is 6.022 into 10 to the power of 23. This is about the Avogadro's constant. You should be remember this value. This about the Avogadro's law. This law was proposed by Avogadro in the year 1811. Then this law states that equal volume of all gases at the similar temperature and the pressure. Similar conditions of temperature and the pressure contains the equal number of molecules. Then example for that is one volume of CO2 at STP contains the 6.022 into 10 to the power of 23 molecules. Like that only, there is one molecule of oxygen at STP contains the, that is 6.022 into 10 to the power of 23 molecules. This about the laws of chemical combinations. That is the law of conservation of mass, law of definite proportion, then law of multiple proportion, and Gale-Lussac's law of combining volumes and Avogadro's law. Thank you.